In this video, we're going to find the formula for the area of a parallelogram. Use the moving and additivity principles to find the areas of the parallelograms, then use patterns to find a general formula for parallelograms. So we're going to use the strategies from the last video to figure out what the formula for a parallelogram is. So notice these shapes, they're not rectangles, they're similar. But if we can use the strategies to make them look like rectangles by using moving and additivity and not changing the area, just cutting and moving the different pieces, then we can find the area. Okay? And then we're going to look for patterns and see if we can figure out a general formula for the area of a parallelogram. So let's look at the first one. Okay, I am going to cut a line straight down here. So remember, my goal is to make a rectangle, so that makes me want to drop a straight line down. We call that dropping a perpendicular because this is 90 degrees right here. So imagine, and if you want to print out an extra piece of this page, you could actually use scissors to cut this and move the pieces. So I can cut this, and notice this is the same length as this right here. And notice this is the same length as this. So these areas, the area right here is equal to the area right here. So now I'm going to highlight our new figure. And this area is equivalent to the area of the original parallelogram. Because I cut off this piece, I moved it over here, and now this is a rectangle. This length is 1, 2, 3, 4. This length is 1, 2, 3, 4, so it's actually a square. Okay. And if I want to find the area of this, it's 4 times 4, which is 16. We weren't told the type of units, but I'm going to write units squared or squared units. So there's 16 squares that fill this up, and that's equivalent to the area of the parallelogram. Okay. Let's look at the next one. This one is a little bit trickier, but I'm going to use the same idea. So we want to turn this into a rectangle. So I'm going to start dropping perpendiculars. So I'm going to start right here. I'm going to make a cut there. And I'm noticing that this is too wide. Okay, so I want to make another cut here because I see this piece right here, this triangle would be too wide, and I can shift it over. Okay, so let's start. I'm going to start with this piece because it looks easier. Okay, and I'm going to shift it over here. Okay, now notice it's a little more than too high, and actually I can tell it goes up to here. So I'm going to draw this side here and this side here. Okay. I'm going to draw 1 because it corresponds to this area. Now we're going to move this piece into here. Let's see what this looks like. Now I'm going to put some blue lines here so we can see how they correspond. Well, this blue line, we can think of shifting this over, and it would be right here. It's equivalent to that. So these two pieces have the same length. And then notice this piece right here has this length. So I just took this piece and shifted it to the right to put it under here. So this piece right here is equivalent to that piece. Now notice I have a rectangle now. I'm going to shade it green. So this rectangle has an equivalent area to the original parallelogram. Let's see what the units are. So this is 2 units wide, and the height is 1, 2, 3, 4, 5, and it's 5 units high. So to find this area, we'd multiply 2 times 5, and we'd get 10 square units. Oops, it's supposed to be a square, not a question mark. So now we want to see, this can be a little bit tedious, so how exactly do these numbers correspond to the general structure of the parallelogram? Okay, so now I've erased the pictures that we have so far, and that's okay if you still have them on your packet. I just want you to see this without all of the different shading. So where can this 4 times 4 come from? Well, in terms of this parallelogram, notice that this length, 1, 2, 3, 4, which we call the base is 4 units. Okay. Now this side right here isn't 4 units, it's going to be longer, okay? But the other 4 units is coming from what we call the height, and that's the distance, the perpendicular distance from one base to the other. Okay. So notice this distance is 1, 2, 3, 4. Okay. So if we call this value the height and this value the base, the area equals the base times the height. Now let's see if this works for this parallelogram. Okay, well, here's the base, that's 2. Notice this base, it's equal to its length of its parallel side. Okay, so that's 2 as well. Okay, these sides also have equal length, but now I want the height. Now remember how we found the height here? It was the distance between these 2 bases. And this seems weird because if we try to find that distance by drawing a perpendicular line, okay, we can't get exactly up to the top because they don't overlap. But here's what we can do. Think of starting at the top base and drop a perpendicular until it's at the same level as the other base. So we have this distance. And there's our right angle. And we're going to call this the height. Okay? So it's the shortest distance from the top base to the bottom base by drawing a line straight down. And notice that's 1, 2, 3, 4, 5 units. Okay. And that gives us our 2 times 5. So again, we get area equals base times height. So in general, the area of a parallelogram is its base times its height. And that seems easy enough, but remember, okay, when you're finding the height, okay, the height is not necessarily a side length. Actually, if it's a rectangle or a square it is, but if it's a parallelogram, it is not a side length. It is that distance between the 2 bases, which sometimes you can find by an interior line that goes from one base to the other, and sometimes it's going to be outside the figure, but you need to find that straight line distance.